All right, so at this point we've got 4 players and they're all moving in a different direction. And we did that by learning the one line of code and sending them off on their merry way using this beautiful thing. So you learned that the direction the players were going were because of this chunk right here, the vector3.forward. So for example, vector3.forward moves you in the z-axis positively. So the z is this blue line, which means it's going to move it this way. And I think I have a little picture here for you where I've drawn out the axis. So vector3.forward is going to move it that way, right? It's the z-axis. Whereas vector3 to the right is going to move it in the x direction positively. And we haven't looked at the y direction yet, but that would be another vector3 where you could move it up along the y-axis. So try not to get too complicated. If I want to move my player by myself, like if I was holding a controller and I wanted to just freely move my character, I have to be able to move in the x direction and the z direction and anything in between and all around, right? I can go diagonal, I can go completely in the x direction, I can go negatively in the x direction, yada yada. So the problem for today's video is I don't want to use vector3.forward because that's going to lock me in one direction. It's going to lock me in the z direction, right? The positive z-axis. So I need to make my own vector so that I can choose where I want to go. I can choose where that arrow is going to take me. Now, I don't know if this is going to clear things up, but if you haven't taken physics yet, and I guarantee you haven't taken linear algebra if you're still in high school, you probably don't really know how vectors work. And the confusing thing about this is my axes are different. In math, we have the z-axis going up and down, just like we did in Blender. And I've got the y-axis here, and I've got the x-axis. So basically, a vector is just a direction. So if I wanted to move from the center of this origin to the right along the x-axis, that would mean my vector would be, well, there's 3 values. I'm going to move 1 in the x direction, and I'm going to go nowhere in the y and the z direction. And as you can see, my arrow points along the x-axis, and that's where my character will move. What if I wanted to move along the y-axis? Well, this time I'm not going to go any direction in the x. I'm going to go 1 in the y, and I'm going to go 0 in the z, right? X, y, z. And there my character will move in the y direction. So what you're seeing right now is just vector3.forward and vector3.right. What if I wanted to go the opposite direction in the y? What if I wanted to go into the negatives of the y? Well, then I could just put a minus on the 1, and it's going to go -1 in the y direction. But when I'm moving my player, if I'm playing the game, I'm not just going to go x's and y's. I'm not just going to go completely 90 degrees perpendicular. I could go wherever I want. So maybe I'm going to go 3 in the x direction, and I'm going to go 2 in the y direction. And now I've got an angle. So now I can move anywhere in between the x and y value. I can move anywhere on this plane. And so that's today's job, is to be able to make these vectors so that we can move anywhere. And if you don't understand any of this vector stuff, that's fine. But some of you will understand it, and some of you will have questions about why we're doing what we're going to do. And hopefully this kind of explains it. So how do we do that? Well, let's go into Unity and let's create another C# script. Let's call this player controller, because I'm actually going to control my player. I'm actually going to decide where my player is going to move. So with this script, once we open it up, we're going to do a new way of moving where we're not just stuck to one particular vector, whether it be forward or right or yada yada. So in the update method, because I'm updating my movement all the time when I play the game, so that's why I'm going to write code in the update method, there's 2 things we have to do. First, I have to get some numbers, right? My vectors were made from numbers. So the easiest way to get these numbers is to first create a float variable, because float just means number. And I'm going to say move x. I'm going to call this variable move x. So I'm not just going to say this variable is equal to 1 or it's equal to 0, because the player gets to decide what it's equal to, right? When the player moves, they're basically telling me where they want to move. So we need to create a vector for them. So how does the player move? Well, typically when you're playing a PC game, you move with the WASD keys, right? Or maybe you move with the arrow keys. So there is a lovely built-in function called input.getAxes. Open up a pair of parentheses and type in horizontal inside the quotations with a capital H. You cannot spell this wrong. This has to be spelled exactly the way I have it, or you're going to have an issue. So what does this line of code do? Well, if you go // you can write a comment, and this isn't code. This is just words to help you understand the code that you're writing. Anything in green isn't actual code. Your computer just ignores it. So floatMove.x means that when the user presses either A or D on their keyboard, because A and D is typically how you move left and right, this variable will be equal to 1. When they let go of the key, in other words, they don't want to move left or right, they don't want to move horizontal, it will be equal to 0. So what did I just do there in terms of this vector stuff? Well, if they wanted to move in the right direction, this vector is going to have a 1, which means we're going to go to the right. But as soon as they let go of that key, it's going to go back to being 0. And as soon as it's back to 0, we're not going to get any movement. And I should say this variable will be equal to 1 or -1. Because if they move to the left, if they press the A key, they're going to go -1. They're going to go to the left. Now, the confusing part is because this graph shows the z-axis as the horizontal, kind of the height axis, the 3D axis. Whereas in Unity, it's the y-axis that gives you that jumping space. So really, we're x's and z's in Unity, even though this demo shows y's and x's. So I'm not moving in the y direction, I'm also moving in the z direction, right? That flat plane. And this is going to tell me how much to move in the vertical direction. So this variable will also be equal to 1 or -1 if I press the W or the S key. And same thing. So what does that mean? Well, not to confuse, because we've got a different axes here, but pretend the Z was the y-axis here. If I wanted to move in the y direction, that vector is going to be equal to 1. So now I'm also moving in the y direction. If I wanted to move in the negative y direction, it's going to be equal to -1 if I have my S key pressed. So now with these two numbers, I've covered every type of direction. I can cover this whole plane that spans y and x. But in Unity, that means I can cover this whole plane that spans x and z. I've covered every distance. This is confusing stuff. So if you're still with me, that's good enough. So all I've done is I've gotten a 1 or a 0 or a -1. All I've gotten here is a 1 or a 0 or a -1. These are just numbers. So what I need to do is I need to create a vector 3 using the, I'm creating a vector 3, and let's call this vector the move vector, because this is ultimately the direction that I want my character to go. And this vector is going to be equal to a new vector 3. And 3D vectors have 3 values, right? They need an X, they need a Y, they need a Z value. Except I'm not manually punching in these values because these values are going to be from here. Your X direction is going to either be -1, 0, or 1. So I'm going to say move X. We aren't talking about Y movement, right? We haven't talked about any jumping. So I'm ignoring the Y axis. So I'm just going to put a 0 there. And lastly, that Z direction is going to be in move Z. And this has created a vector, this line of code. This has created this blue arrow. This has created the direction that my character wants to go. So the very last thing is something we've already done before. It's the actual movement of my player. And so what that's going to consist of is the same line of code where if I'm changing the movement of a game object, right? If I'm changing the position of my player, that's under the transform component. So I'm going to use transform. There's a lovely helper function where I can use .translate. And this time I'm not moving in vector3.forward. I'm moving in this move vector direction, the vector that I just created. And how fast do I want to move? Well, maybe I want to move 5F or something, but I know from last video that we should set the speed, public float speed equals, I don't know, let's just go 1F. And instead of putting a magic number here, I can just put the speed here. And the last thing is the time dot delta time as the correction factor. Apologies, I always do this. I need these bad boys. We're multiplying. So I've taken one line of code and I've added 3 more lines of code, complicated as they may be. And I'm going to save this script and let's see how this works. So back in Unity, remember, a script is logic, but the logic is not applied if you don't put the script on your game object. So I'm going to put this on player 1. So now if I click on player 1 in my inspector, I should have 2 scripts. And I believe I have 3, for I maybe made this script previously. So I'm just going to remove that and do this again. So player controller goes on player 1. And now I've got the 2 scripts. I've got the first script we made in the first video, and I've got this script we made now. You can go ahead and remove player 1 components or the player 1 move script because we've created a new one. And let's see if I have movement with my WASD keys. So player 1 is sitting right there, but now I can press my WASD keys, and as you can see, I'm moving in all of these different vectors. I'm moving in all of these directions. So we are advancing our game one step at a time, and if everything I said to you in this video went on one ear and out the other, that's okay. As long as you'll always have access to this code if you want to incorporate movement for your player. But I know some of you are going to be curious about why this code works the way that it does. And hopefully this visualization with the vectors maybe put some of those questions to rest. So anyways, very cool stuff, very mathy.